Hello everybody, my name is Kyle McCulloch. Today we're going to talk about using artificial intelligence to detect malware. So a little bit about me. I've been in IT for about 12 years, maybe a little over, somewhere around 12 years. Started out as a network technician, went into help desk, and then moved up server admin, and now I'm an IT infrastructure manager for OSU at the Mulgee campus. So me and my team were responsible for the security, the IT security of the campus, the servers, the networking, the security cameras. We have quite a bit under us that we manage. Currently, I'm working on my master's degree from Oklahoma State University. I only got about a year left, and I'll be done. And my focus is split between data science and information assurance. So what is malware? Malware is an umbrella term for a lot of things. Viruses, adware, spyware, worms, Trojan kits, you name it. It all falls under malware. And what we're really looking at in this discussion is we're talking about end-user devices and protecting end-user devices that we manage. So this can also be, term be used for protecting your servers, because you should always have antivirus and all that installed on your servers. So how does traditional malware protection work? So the malware software is going to run through all your programs on your computer, as well as anything new you download, and it's going to hash out every single program, and that's going to create a hash code. And that hash code is going to be verified against a database that the manufacturer of that antivirus has, like Kaspersky or any of those others. And if it finds an identical match, it gets flagged as malware and it gets removed from your computer. But what if that malware is not in that database? So this is something that happens every day. Hackers take a program that's been working this good, but it's in everybody's databases, and they change one small thing. In order to change the hash output, all you got to do is put an extra space somewhere, and that hash completely changes to something different. So they can go in there, they can add a comment, add a space, anything like that, and that completely changes the hash output. And, malware is detected, new malware is brought into the world every 7 seconds. So every 7 seconds, new malware has just been reintroduced. But it's not all brand new malware. It's the same stuff that's out there. It's just changed just slightly to get around the hash setting. And every day, there's 350,000 malware versions are identified. So how can artificial intelligence help with this problem? So first of all, artificial intelligence is another umbrella term for a lot of things. It's for machine learning, natural language processing, vision, speech, robotics, lots of things. So it's pretty much, it's a computer making a determination upon the data that it has available to itself. For us, we're going to be really focusing on the machine learning aspect of artificial intelligence. So inside machine learning, machine learning is has two classifications: supervised learning and unsupervised learning. So with supervised learning, we're going to feed it a bunch of data. We're going to tell it what that data is, and then we're going to feed it brand new data, and it's going to make it's going to determine what that new data is based upon data that we've already given it. So the more data we can put in, the more accurate that model is going to be. So underneath supervised learning, we have classification, which is basically, is it dog or a cat? Car or truck, stuff like that is classification. It's trying to name what something is. Regression is basically, you put up a flagpole and say, I want a number between 0 and 100, and it's going to give you a number somewhere between there. So regression is used in, like, say you want to predict the stock price for tomorrow, you'd use a regression model to make that happen. The other category that we have is unsupervised learning. So with unsupervised learning, you're putting all the data together, and it clusters them together based upon similarities that you set up in your model. There's a lot of different ways to do that. Distance is a really good one, where it kind of groups them all together based upon how close they are to each other. So first we're going to talk about classification. Here's a real-world example of classification. This is an image from an analytics camera somewhere. It looks like New York, but it's able to, because of the data that it has, identify what's a car, what's a bicycle, trucks. It even identify a traffic light. So using previous data that it has, it's able to tell new data that's presented to it what it is. So how does this work with malware? Well, basically we feed the program, we feed the model a bunch of data that we know malware and we know normal programs. And we tell it what's what. And then you feed it new data and it tells you if it's malware or not. So let's dive a little bit deeper as far as how this really works. So this is an exe file. This is how, if you would break down an exe file, what it really looks like. And this is going to be really similar to doing a packet capture. With Wireshark, right? You have a header, you have data, right? And all that data is in a hex code format. Exe file is just like that. So we got headers, we got code, we got imports, right? And what a lot of these programs do is they just kind of collect metadata from this stuff, like how big is each section, right? And then compare that to other programs of what they know about it. So for example, malware is pretty small programs. It doesn't need to be very large. And so the code section is normally pretty small on them. And you can compare that with what you got and see, if those two are really similar to each other. So this is an inside exe file for Firefox.exe. Again, we kind of have the same hex code stuff throughout here, but we got different columns over here and different data. So, we can literally just compare this to something else, that we're questioning and determine how similar they are to each other. And this is really how Kaspersky Labs, this is the model they use to determine if something new they got is malware or not. So they bring the object in, which is the program. They pull out all the low-level features. They analyze it. They're getting all this metadata and everything. They feed all that information into what's called a multi-layer neural network. It's kind of like a brain. So what it does is it looks for shortcuts and everything in the data and tries to memorize where things go to make a determination of what it is. And so from the output of here, it's able to go, well, is it this type of malware? Is it this type of malware? Is this type? So this model is really used for determining what kind of malware it is and not just, yes, it's malware or no, it's not malware. So let's talk about some of the pros and cons. So this approach really works well when you're looking to find those programs that just got slight modifications on them to get around the hash. And so that's what this is good for. What it's not good for is brand new ideas that have come out of malware that it doesn't look like anything else out there, like WannaCry or any of those other viruses that just wreaked havoc on systems because it was so different. And so how do we detect those type of programs? So that's the other sections. We're going to use the unsupervised learning and clustering to determine that. So clustering, again, we're looking for similarities in the data to group them together. And as you can see here, this is using distance vectoring is what it's called to make assumptions about if it belongs to a certain cluster or not. One of the really neat features of clustering is outlier detection. So again, we have our clusters here, but these little guys up through here they're too far away. So these all get flagged out as being outliers. So let's look at a real-world example of how this can work. We have a program here, it's called Paint. We're all familiar with it. We've played with it since we were kids all the way up probably till now. And it does one thing and does one thing well. It allows you to create beautiful works of art on your computer. But something that Paint does not do and never has is going out to a website and try to download something. So since if Paint ever did this, we would know, hey, you're outside of what you normally do, and we get to classify this as being an outlier detected. So let's talk about some of the cons of clustering. It requires a long history to develop a really good baseline. You know, there's a lot of programs out there that got a lot of features that most people don't probably ever use, or they may get informed about it after, say, using it for a couple of years that they could do something and decide to do it. Those types of events could trigger an alert with using outlier detection. And it requires a team to investigate each detection. You know, it really needs to look into, is this malware or is this not? If you don't detect that correctly, then you could, basically put malware into your baseline. So who's doing this? CrowdStrike is the biggest player in the game as far as using AI to detect malware. They don't just collect the baseline information from one computer or from your computers that you have in your organization. They do it from every person that is a customer of theirs. That's why the first part's called crowd, is because they're using everybody that's a subscriber to collect that baseline information. And then when a outlier does happen, you have a much higher probability that that is true malware. Another cool thing is if one person detects a brand new malware, they tell everybody about it, which just kills the growth of that virus. Just like, some of the viruses out there that just never got to go anywhere because they got detected too soon. Another person that's in the field is Avast Free Antivirus. They got a new feature out that's called Malware Similarity Search. Uses the clustering or the classification principle to basically detect the malware that's trying to get around the hashing principle of the traditional malware detection. Windows Defender Security Center, they're right now experimenting with using AI for detecting new malware. And they're actually looking at, it's right now pre-production, but they're looking at deploying that to the enterprise class customers sometime this year. So if you operate a business and everything and you use Windows Defender Security System, that's going to be a new feature that you're going to have. And that'll be something that lives on your server that does the malware detection. And then we have Kaspersky Labs, who is doing it only really in their lab environment. They're not doing it on each individual computer. So with this, do we still need traditional malware protection? The answer is yes. And the reason why is it helps us with defense in depth. Defense in depth is an approach where we're going to use layer upon layer upon layer to find problems and to eliminate them. And this really falls into the visibility layer of defense in depth, to where we're not using one method to try to find malware. We're using multiple methods. We're using hashing to find them. We're using clustering or classification to find similarities between the malware programs. We're using outlier detection to detect brand new malware. So we're using every tool that we have available to us to try to keep our desktops and our servers safe. Thank you guys so much for watching. I hope you got something out of this. If you did, give me a thumbs up on YouTube, hit the like button, put a comment in saying thank you for the content. I'd really appreciate it. And guys, have a great day. Thank you.